Alrighty, so this is lesson 3.5. This goes with your pink foldable 3.5 modeling with linear functions. So we first off are going to start off with our I can statement. Alrighty, so our I can statement. I can find a missing value given a linear scenario and interpret the meaning of the slope and y-intercept. So I'm going to read that again for you. I can find a missing value given a linear scenario and interpret the meaning of the slope and the y-intercept. So some things to remember. We are talking about linear functions written in the form y equals mx plus b. Remember that linear functions written in this form have two parameters. Remember we said yesterday, or actually I think on Thursday, that parameters are things that we need, right? These are the things we must have in order to write an equation in slope-intercept form. So the two parameters are slope, that's your m, and the y-intercept, that is your b. Now on Thursday, we spent quite a bit of time calculating slope given 2 points, and we talked about how to find the y-intercept by either using one of those ordered pairs and plugging in those as your x and your y into the slope-intercept form, as well as your slope. Today, we're going to spend a little bit of time talking about how we use those ordered pairs to calculate slope and what we do with that slope, what it means in terms of a real-world situation. So remember that the slope, m, always tells us how fast the output is changing relative to the input. Remember that your slope is the same thing as your rate of change. Whether it's a constant rate of change, which slope is constant, or you're finding it amongst an interval, which would be your average rate of change. The y-intercept tells us how much we start with. Remember that the y-intercept is where you begin. The y-intercept is where you begin. So that makes sense that it tells you how much you start with. It's the beginning value. All right. So example number 1, a car is traveling along a road at a constant speed. After 1 hour, the car is 72 miles from Chicago. After 3 hours, the car is 188 miles from Chicago. So it sounds to me like there's a couple of ordered pairs in here. Our time, 1 hour, that's going to represent X. This is our time. And our distance, 72 miles, this is going to represent Y. It's our distance. Then our second ordered pair that we can see after 3 hours. Again, this is going to represent x, and 188 miles, this is going to represent our y. So question A says, model the information given in the problem as two coordinate pairs. Well, that's pretty easy for us to see. We have 1 and 72 as our first ordered pair. And we have 3 and 188 as our second ordered pair. Okay. So now we're asked, question B asks us to find the slope of the line that passes through those 2 points. So that means we need to use the slope formula. Remember, that is y2 minus y1 over x2 minus x1. And that's y sub 1, y sub 2, right? So if you remember from Thursday, the first thing that I want you to do is go ahead and label your ordered pairs. This is my first ordered pair, 172. So x sub 1 and y sub 1. My second ordered pair, 3, 188. This is x sub 2 and y sub 2. All right, so using the slope formula, I'm going to plug in these values. So y sub 2 is going to be replaced with the number 188 minus y sub 1, which is the number 72, over x sub 2 is the number 3, and x sub 1 is the number 1. Now we're just going to do a little bit of math. 188 minus 72 is 116. 3 minus 1 is 2. And when I put this into my calculator, 116 divided by 2 is 58. So our slope is 58. Well, what does that mean? It says, what does this slope represent? Well, we can think of our slope as 58 over 1. Remember that the y-coordinate represents the distance, which is in miles, and the x-coordinate represents the time, which is in hours. So we can read this as a unit rate, 58 miles per hour. What does that mean? Well, that just means that the car is traveling at a speed of 58 miles per hour. So that's what that slope means in the context of the problem. The second thing that we're asked to do is find the equation for the distance. And we're asked to find the equation for the distance that the car is from Chicago, and we're going to use the letter D. So the distance, remember, was y, and then we're using t, time. Well, that was x. So we're writing an equation for the distance the car is traveling from Chicago as a linear function of time. Okay, so remember, if we're going to write a linear equation, the first thing that we need to do is we need to find the starting point. We need to find out where we begin. So the first thing that we're going to do is use our slope, which we said was 58. And we have to pick one of those ordered pairs. I'm going to use the ordered pair 172. And I'm going to plug that into y equals mx plus b. And I'm going to solve for b. Remember that this is my x and this is my y coordinate. This is my x and this is my y coordinate. And actually, I'm going to box this in because that x up there represents the time. Okay, so let's see. I'm going to plug in some values. So I'm going to do that right over here. So I'm going to replace the y with the number 72. 72 equals, I'm going to replace my m, my slope, with the number 58, times x, well, x is the number 1, plus b. Well, I know that 58 times 1 is 58, so 72 equals 58 plus b, And I know if I want to get B all by itself, I have to subtract 58 from both sides. And when I do that, I find out that my starting point, B, was 14. So now I have all the information that I need. I have both parameters, and I can write my equation. Y equals my slope, which was 58, times x plus 14, which is B. Now the last thing that I'm going to do is I'm going to switch out the variable y with a d, which represents my distance. So d equals 58. And I'm going to replace the variable x with a t, because t represents our time, plus 14. So this is our equation that we're going to use. Alrighty. Example number 2. Snowfall is coming down at a steady rate. That's going to tell us our slope, right? Steady, constant. Prestel decides to measure the depth of the snow on the ground. After 4 hours, the snow is at a depth of 9 inches, and after 8 hours, it is at a depth of 14 inches. Well, that sounds again like two ordered pairs. Time, x, is going to be 4. The depth of the snow, 9 inches, is going to be y. Again, our second ordered pair, 8 hours, time is going to be x, and the depth of our snow, y, is 14 inches. So it says express the information given in this problem as two coordinate pairs, h standing for the hours in time, and d standing for the depth of the snow. So I know that my two ordered pairs are 4 for 4 hours and my depth of 9 inches, and the second ordered pair, 8 hours and a depth of 14 inches. Okay. Question B says, find the slope of the line that passes through these 2 points. So again, I'm going to use my slope formula. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, so I'm going to go back up to my two ordered pairs and label them. This is my first ordered pair, x sub 1 and y sub 1. This is my second ordered pair, x sub 2 and y sub 2. And so I'm going to just replace these values into this formula. So y sub 2 is actually 14 minus y sub 1, which is 9, over x sub 2, which is 8, minus x sub 1, which is 4. So let's see, 14 minus 9 is 5, and 8 minus 4 is 4. Now notice it says to express this as a decimal. So I'm going to use my calculator and take 5 divided by 4. And when I do that, I get 1.25. Now let's remember what each one of these numbers in our slope represent. The y coordinate represents my depth, which is in inches. And the x coordinate represents my time in hours. So this means that I have 1.25 inches of snow falling each hour. So 1.25 inches of snow per hour. Okay. Question C says, okay, now let's find an equation of the line that passes through the 2 points. Notice that it asks us to write the equation as D equals m times h plus b. But remember that the depth of my snow is actually the variable y, and my hours is actually x. So when you're given a question like this where it is asking you to use other variables, don't get distraught. Think about what those relate to. You can always write your equation using the variables y and x and then substitute them out at the end, which is what we'll do. So I know that if I want to do this, the first thing I have to do is find b. I have to find the beginning value, how much snow was on the ground when Prestel started measuring this. Okay, so in order to find B, I need to use my slope. Well, I know that my slope is 1.25, and I need to use one of the ordered pairs. I'm going to use the ordered pair 4, 9. I'm going to use the ordered pair 4, 9. Okay, so I'm going to plug these in. Remember, this is just an x and a y coordinate. So I'm going to substitute these values into y equals mx plus b. So the value I'm using for y is 9. 9 equals my slope, m, which is 1.25, times x, which is 4, plus b, my beginning value. So let's see. 1.25 times 4, well, that equals 5. Okay, I'm going to subtract 5 from both sides. So 4 equals B. What does that mean in terms of the problem? That means that there were 4 inches of snow on the ground when Prestel started recording snowfall. So there were 4 inches of snow on the ground when Prestel started recording the snowfall. But we still have to write an equation for this. So y equals my slope, which is 1.25, times x plus 4, which is my beginning value, right? My beginning value when this started was 4. And lastly, I'm going to just replace my variables. I know that y is the same thing as d, the depth of the snow. Still has the same slope, 1.25. But I'm going to replace the x with an h for my time, plus 4. Okay. Alrighty. Next question. Oh, we have more questions here. Sorry. What was the depth of snow what was the depth when the snowfall began? Well, that's the value of B, and it was 4 inches. Question E says, what would the depth be after 12 hours? Well, that's the same thing as saying, let your time, which is hours, equal 12. So I'm going to take my equation, D equals 1.25 times 12 plus 4. So let's figure out what our depth is. So 1.25 times 12 is 15. And 15 plus 4 is 19. So what does that mean? That means after 12 hours, there was 19 inches of snow. After 12 hours, there was 19 inches of snow. Okay, let's do example 3. Alrighty, so example 3 says a 696 gallon water tank is draining at a rate of 14.5 gallons per minute. That means that we're losing water. So that means that our slope, 14.5, is going to be negative because we're losing water. The volume of the water in the tank in gallons is a linear function of the amount of time it has been draining. So the first thing that we need to do is create a table of values to model the linear scenario. Well, I want you to go to your calculator and let's start with this. When the time is 0, when we first begin, how much water is in the tank? Well, there's 696 gallons of water in the tank. That's our B value. That's our beginning value. So B equals 696. And we know that because we know when x is 0, that's when we have our y-intercept. We also said that our slope, the 14.5, is going to be negative. So we have an equation, y equals negative 14.5x plus 696. So I want to write down some calculator operations. I want you to go to your calculator. Okay. And on the y equals button, you're going to write negative 14.5x plus 696. Then you're going to press the second and the graph button. Why? That's going to give us a table. We're just going to copy down the numbers that are in our table. Okay? So when x is 1, after 1 hour, I have 681.5 gallons. After 2 hours, I have 667 gallons. Now, I want you to see that your time increments change, right? Because I'm just trying to get you used to looking for the input. This is your input value, so you can determine the output. So I didn't go specifically in order. So when I let x equal 5, my output is actually 623.5 gallons. When x is 10, my output is 551 gallons. When x is 15, my output is 478.5 gallons. When x is 20, my output is 406 gallons. When x is 25, my output is 333.5 gallons. And when x is 30, my output is 261. So yes, I'm using x in place of the t. That's how I put that into my calculator. And I'm using y in place of the v of t, that function. Okay. So the question asks us, what is the rate of change for this linear function? Well, we know that rate of change, that's the same thing as slope. And our slope is negative 14.5. What does that mean in the context of the problem? Well, this means that the tank is losing 14.5 gallons of water every minute. Okay, losing 14.5 gallons of water every minute. Asks us to write a linear function. Well, we're going to use the variables from the table. So we know that y is replaced with v of t equals, well, our slope, which is negative 14.5, and our time is measured in t instead of x, plus b, our beginning value, which was 696. Okay. How long will it take for half of the tank to drain? That's an interesting question. This is asking us about time. How long will it take? That means that we need to find the time. We need to find the time. So we're going to solve for t. Okay? Well, half of the tank, let's see, if I started with 696 gallons, and I want to figure out when it's half full, that means I need to figure out when the volume of the tank is equal to 348 gallons. The volume of the tank is equal to 348 gallons. So I'm going to use this equation, V of T equals negative 14.5 T plus 696. But I'm replacing V of T with 348. And I'm going to solve for T. So 348 equals negative 14 14.5t plus 696. So first, I need to subtract 696 from both sides. And that's going to give me a negative value. Negative 348 equals negative 14.5t. Then I will divide both sides by negative 14.5. And when I do that, I find out that t equals 24. Now remember, t is our time in minutes. So how long will it take? It will take 24 minutes to drain half of the tank. 24 minutes. This last question asks us how many gallons of water, that's asking about our volume, how many gallons of water are left in the tank after 40 minutes? So that means that we're going to let t equal 40. We're going to let t equal 40. So we're going to use that same equation, V of t equals negative 14.5 t plus 696. And we're going to replace t with a 40. So V of t equals negative 14.5 times 40 plus 696. Well, negative 14.5 times 40, when you use your calculator, you find out that negative 14.5 times 40 is negative 580. 580 plus 696, well, that means that the volume left in the tank, the volume of water left in the tank after 40 minutes is 116. So the volume of water in the tank after 40 minutes is 116 gallons. Okay, so I want you to make sure that you finish filling out your journal. Put this into your journal, fold it in half and glue it into your journal, okay? And then your homework is actually to work on page 12 and 13, lesson 3.5, modeling with linear functions. Lesson 3.5, modeling with linear functions. And I want you to have a great day and be excellent for the sub. Thank you.